Ever wonder how critical decision-making is in the realm of machine learning? Well, it's the heart and soul of it. Machine learning is all about teaching computers to learn from data, to make informed decisions. Just like us humans, machines learn from experiences. These experiences in the realm of machine learning are nothing but data, a lot of data. The key to making sense out of this complex data is decision-making algorithms. These algorithms predict outcomes based on the given data, helping us unravel hidden patterns and insights. They help us navigate through the labyrinth of data, making the right turn at every decision point. In this complex world of data, decision-making is not just important, it's indispensable. It's the compass that guides the machine learning ship through the vast ocean of data. One such algorithm that excels in decision-making is the random forest algorithm, a powerhouse in predictive modeling. So, what exactly is this random forest we're talking about? Let's unravel the mystery together. Imagine you're in a forest. This isn't just any forest, but a forest of decision trees. Yes, you heard right, decision trees. In the realm of machine learning, these trees are a vital tool for making sense of complex data. But sometimes one tree isn't enough. That's where the random forest comes in. Random forest is a supervised learning algorithm that uses the ensemble learning method for classification and regression. Now, that might sound a bit complex, but let's break it down. Supervised learning is a type of machine learning where we teach the algorithm what the correct answers are. It's like giving a student a study guide before a big test. Ensemble learning, on the other hand, is like gathering a team of experts, each with their unique perspective, to solve a problem. In the case of random forest, these experts are decision trees. Now, how does a random forest operate? It constructs multiple decision trees and then puts them to work. Each of these trees makes a decision based on a random subset of the data, hence the name random forest. For classification tasks, each tree in the forest casts a vote for a class, and the class with the most votes becomes the model's prediction. It's like a democratic voting system where the majority rules. On the other hand, for regression tasks, the forest makes its prediction by averaging the outputs of each tree. Think of it as taking the opinion of every expert and finding the average to make a final decision. So to recap, a random forest is a sophisticated algorithm that creates a forest of decision trees, each working on a different piece of the dataset. These trees then cast their votes or contribute to an average prediction, giving you a robust and accurate output. In essence, a random forest is a collection of decision trees, each casting a vote for a predicted outcome. And that, my friends, is the power of the forest. Now, let's demystify how a random forest works, step by step. At its core, a random forest is a collection or forest of decision trees. But instead of relying on a single tree's judgment, it seeks the collective wisdom of the forest. Let's break down this process. First, we start with what's called bootstrapping the data. In this step, we create multiple subsets of the original data with replacement. That means some data points may appear more than once, and some might not appear at all in a subset. Imagine it like shuffling a pack of cards and then picking out a handful. Each of these subsets will fuel the growth of a single decision tree. Next, we grow the forest. Each decision tree in the forest is trained using a different subset of data, but there's a twist. For each split in the tree, only a random subset of the features is considered. This randomness ensures that each tree is different and prevents overfitting. It's like asking different groups of experts to solve a problem, each group having access to different information. Once the forest is grown, we're ready to make a prediction. When a new data point comes in, each tree in the forest makes its own decision. The final prediction is then made through a majority vote. If it's a classification problem, the class with the most votes wins. If it's a regression problem, the average prediction of all the trees is taken. It's like asking all the experts to vote on the best solution. Now, you might be wondering why we'd go through all this trouble when we could just use a single decision tree. The answer lies in the power of the ensemble. A single tree, while easy to interpret, is prone to overfitting and can be overly influenced by noisy data. A forest, on the other hand, averages out the errors of each tree, leading to a more robust and accurate model. The random forest algorithm also offers us a measure of feature importance. It calculates how much each feature contributes to the improvement in the prediction accuracy. This can be incredibly useful in understanding which features are driving your predictions. Another great advantage of random forests is that they can handle a large number of features and don't require feature scaling. This makes them a versatile tool for many machine learning tasks. And finally, random forests are parallelizable. That means you can train multiple trees at the same time, making them a great choice for large data sets. So, you see, the power of random forest lies in its ability to reduce overfitting through the ensemble of decision trees. Now, are you ready to see the random forest algorithm in action? Consider a scenario where we are given a data set of patients with various health parameters, and we need to predict whether a patient will have a heart disease or not. By using the random forest algorithm, we can consider various health parameters as the features and the presence of heart disease as the target variable. The random forest algorithm will create multiple decision trees, each considering a random subset of features and patients, and will take a majority vote to predict the final outcome. Let's move on to another example. Suppose we have a data set of movie reviews, and we need to classify whether a review is positive or negative. The random forest algorithm can be used to extract features from the text, such as the frequency of certain words or phrases, and create multiple decision trees to predict the sentiment of the review. Now, let's dive into the numericals. Consider a data set with 5 features, x1, x2, x3, x4, and x5, and a target variable y. We randomly select 3 features and a subset of data to create our first decision tree. After calculating the Gini index, or the entropy, we find the best split for our decision tree. This process is repeated multiple times to create a multitude of decision trees. Let's raise the stakes a bit. Consider a data set with 100 features and 1,000,000 data points. The power of the random forest algorithm really shines here. Despite the large number of features and data points, the random forest algorithm can efficiently create multiple decision trees and predict the outcome with high accuracy. These examples and numericals not only illustrate the power of random forest, but also its practical applicability. Wondering where you might encounter random forest in the real world? Well, it's closer than you might think. Let's start with banking. Banks use random forest algorithms to predict customers who are likely to default on their loans. This enables them to mitigate risk and make informed decisions. Now, let's move on to medicine. The healthcare industry employs random forest for predictive diagnostics. By analyzing patient data, the algorithm can predict the likelihood of a particular disease, helping doctors make timely and accurate diagnoses. Next is the stock market. Traders and financial analysts use random forest to forecast stock behavior based on historical data. This helps them make informed investment decisions, offering a significant edge in the competitive world of stock trading. And what about when you're shopping online? E-commerce platforms leverage random forest to personalize your shopping experience. The algorithm analyzes your browsing history and purchasing patterns to recommend products that you're likely to buy. Lastly, let's not forget about the world of scientific research. From predicting climate change patterns to understanding the behavior of distant galaxies, random forest aids researchers in making sense of complex data sets. So you see, whether it's banking, healthcare, the stock market, e-commerce, or even scientific research, random forest is hard at work, making sense of the world's data. Indeed, the random forest algorithm is ubiquitous, making our lives smarter and more efficient every day. To recap, random forest is a robust machine learning algorithm. It's a decision-making powerhouse using multiple decision trees to arrive at an optimal solution. We've walked through its inner workings, explored practical examples, and tackled numerical problems. We've also seen how it's applied in real-world scenarios, from healthcare to financial markets. It's an algorithm that's as diverse as a real-life forest, and just as powerful. So the next time you think of decision-making and machine learning, remember the mighty random forest.